This video will cover the slightly trickier question that you get for bond enthalpies. Sometimes you get the overall enthalpy change value actually given to you, and they want you to calculate the enthalpy of a specific bond. So what I'm saying is they actually give you this delta H value, and then there'll be a bond that they want you to find the value of. Let's do an example. It's the best way to understand. Once again, just a warning, you must show your working. Set out your working so it's logical and tidy. If you make no attempt to show your working, then you'll get no marks. Final answer must have units, and it should be to 3 significant figures. Okay, so here's a sample equation that they've given us. The carbon monoxide reacts with steam to produce hydrogen gas. So for those that are not aware, mono means one, so this is carbon monoxide. This is steam, water gas, and it's producing hydrogen gas and carbon dioxide. The equation is always given to you. And this time they've also given us the enthalpy change for the reaction. So it's an exothermic reaction and it releases 41.2 kilojoules. Alrighty. In the question it goes on to say the bond enthalpies for the carbon to oxygen bonds in carbon dioxide and carbon monoxide are different. So they're setting the question up for you to obviously get a little bit nervous at this point because you might not be familiar with these two compounds. Use the bond enthalpies in the table and the enthalpy of the reaction, okay, which is that value there, to calculate the bond enthalpy of the carbon to oxygen bond in the carbon monoxide. Because remember earlier in the videos that I had done, I did say it is expected that you know carbon dioxide consists of double bonds. You might not know that carbon monoxide is actually a triple bond, but regardless, you'd still be able to work this out. So we follow the exact same process. We want to look at all the bonds that need to be broken. So that's just got one bond in it, whereas water's got the 2 hydrogen-oxygen bonds. And on the products side, the bonds we need to form a hydrogen-hydrogen single bond, and we need to form the 2 carbon-oxygen double bonds. Okay, so step 2 is to work out your subtotals. Now, in this instance, we don't know this value, so we could assign it X, or what I've done here is a question mark. But we can sum up everything else. And we can say 2 lots of the HO bond, so 2 lots of 463. When we do our subtotal here, it's going to be the 926 for the HO plus this mystery value X, or question mark. Okay, that's the subtotal for the bonds broken. Bonds formed, again we just use the same process. So you've got your 436 for this bond and 2 lots of 743. So you've got your subtotal there for the bonds formed. Now let's go into using the equation that we know, which is bonds broken minus bonds formed, and put our subtotals in. So we're taking our subtotal of 926 plus question mark, and we're going to subtract off 1922, which is the subtotal we found. And we do know that this will add up to the enthalpy change, which was provided, 41.2 kilojoules per mole. Now it's just straight maths. We're trying to solve this equation to find out the value of question mark. So it is going to be equal to minus 41.2. Now, to put the 926 on the other side of the equal sign to the question mark, that is why it's minus 926. And to put this value on the other side of the equal sign, that is why it changed to plus 1922. So this is just straightforward math. And you'll find your value, and the value for question mark is 954.8. Now don't stop at that point, because you've not actually answered the question, which was find the value which is the carbon-oxygen bond. So this is the bit where you've got to take a little bit, your answer a little bit further and say, well, question mark was the symbol we used to represent carbon triple bond oxygen. And this is the bit that I've got in bold that you need to write. So the bond enthalpy for the carbon triple bond oxygen is, and notice I've taken this value and rounded it to 3 significant figures. So that 8 pushes the 4 up to a 5. So that's where the 955 comes from. It's also an endothermic process. You must put in the plus symbol, otherwise you will get penalised. You won't get excellence for this question if you miss out. Bond enthalpies are always quoted as endothermic values. So you've got your units there, kilojoules per mole, you've got your symbol, and you're done. And that is an excellence question. So I'll do another example in the next video. So if you are watching the videos in order, watch the next one and you'll get another example.